By the end of this lesson, you should be able to state Pascal's principle, explain hydraulic systems, solve problems involving Pascal's principle. Observe the boy's action. On pressing the tube of toothpaste at one end, the paste comes out at the other end. Why does the toothpaste come out when the tube is squeezed? The pressure applied causes the paste to come out at the other end of the tube. Observe the animation of how pressure is transmitted through the paste. When the paste is squeezed at one end, a pressure or a force per unit area is applied. This pressure is transmitted through the paste because a change in pressure at any point in an enclosed fluid at rest is transmitted undiminished to all points in the fluid. What happens if the boy presses it harder? When the tube is pressed harder, the toothpaste comes out faster. We can conclude that when more pressure is applied, a higher number of particles are pushed together, hence increasing the force throughout the enclosed liquid. The pressure is transmitted through the liquid evenly. This will also increase the volume of the liquid coming out of a container or the speed of which. What happens when the piston is pushed in? When the piston is pushed in, water will shoot out of the openings. The force of the piston is transmitted uniformly throughout the liquid. Since liquid is virtually incompressible, the water will shoot out. This phenomenon is called Pascal's principle that states that pressure is transmitted uniformly in all directions in a liquid. Click on the image of Pascal to know more about him. We know that pressure is transmitted equally in all directions inside the enclosed fluid when there is a force acting on the piston S. What is the pressure acting on the piston S? P1 equals to F1 over A1. What is the pressure acting on the piston T? P2 equals to F2 over A2. What can you say about the pressure acting at piston S and piston T? They are the same. P equals F1 over A1, which is equal to F2 over A2. We can write this as F2 equals F1 times A2 over A1. In this case, A2 equals A1. Therefore, F2 equals F1. The pressure acting on these two pistons is the same. What if the cross-sectional area of piston S and piston T were not the same? The value of F2 would be equal to F1 multiplied by the ratio of A2 to A1. The ratio of A2 over A1 is known as the force multiplier of the system. If A2 is 4 times bigger than A1 and F1 equals 20 newtons, what is the value of F2? F2 is 80 newtons and it is 4 times F1. We can see that by applying a small force on piston S, we can produce a force that is 4 times bigger on piston T. This principle is applied in the hydraulic press. A car of mass 500 kilograms can be lifted using a hydraulic lift. The ratio of the cross-sectional areas of the pistons is 1:5, as shown in the diagram. What is the input force required to lift the car? According to Pascal's principle, the pressure applied at one point in an enclosed fluid is transmitted uniformly to every part of the fluid and to the walls of the container. So, the pressure at the two pistons is the same. P equals F1 over A1 equals F2 over A2. Therefore, F2 equals F1 times A2 over A1. F2 equals mg equals 5,000 newtons, and A2 over A1 equals 1 over 5. The force required to lift the car, F1 equals F2 times 1 over 5, equals 1,000 newtons. In this case, an input force of 1,000 newtons produces an output force of 5,000 newtons.